Hello everyone, welcome back to another Tech Tips. My name is Trevor May. I am the VRF and Duct-Free Split Technical Specialist here at Standard Air and Light. And what we're going to be covering in today's Tech Tip is going to be an overview of the new Ductless Vertical Air Handler, which is our 40 MBAA. And basically this overview is going to consist of what this 40 MBA is, what we can do with it, and then also differentiating between our hybrid solutions, which is usually confused with this 40 MBAA, and kind of differentiating between what's what makes them similar, but most importantly, what makes them different. So let's look at an overview of the 40 MBAA vertical fan coil for ductless systems. So this vertical fan coil is a true ductless indoor unit, which means it does not require that piping adapter or that TXV removal kit that we see with the hybrid solutions. So technically this is not considered a hybrid solution, as it is a true ductless indoor unit. It does not have an expansion valve at the indoor unit. Just like any other ductless system, the expansion valve is going to be located at the outdoor unit. So all we really have to do to this unit is, essentially from a piping perspective, is hook up our piping and then of course do our corresponding wiring. So this vertical air handler is available in 2, 3, and 4-ton sizes. Important to note on here that the 2-ton size is the only vertical air handler or 40 MBAA vertical air handler for our ductless systems that is compatible with both the single zone and multi-zone systems, which means if you're looking for an application for a multi-zone system with this vertical air handler, the 2-ton model is the only one that you can mix with other ductless indoor units, such as a high wall, a cassette, and a floor console for a single point connection to one outdoor unit. Now the 3 and the 4-ton sizes are only compatible with single zone outdoor units, and they have new updated single zone model numbers that are specifically compatible with these 3 and 4-ton vertical air handlers. Now, if we look at the bottom right-hand portion of this slide on here, you'll see you have the 38 MAQB 24R that is compatible with the 2-ton air handler. And like we talked about just a second ago, that fan coil is also compatible with the 38 MGR, but only on the 2-ton model. And when we start looking at the 3 and the 4-ton models, they are going to be compatible with the single zone 38 MBR BQ36 for the 3-ton, and then the 48 for the 4-ton. So those are 1-to-1 configurations only. This vertical fan coil offers 4-way installation, so we can do an upflow, downflow, horizontal left, and horizontal right. Now, depending on the configuration, is going to determine whether you need to remove the coil out of the cabinet and then reconfigure it properly, depending on your installation, whether you're doing horizontal left or right. And that information is noted in the installation manual for how to take apart that coil and get it out, and then properly insert it back so that it is configured properly for the application. This fan coil features a constant volume airflow algorithm with a modulating ECM motor, very similar to what we see with the newer residential style products. This does come built with a 24-volt interface, which we're going to need to allow some form of control, wired control for these systems. And we'll get into that 24-volt interface and what we can do with that. But that device comes built in with this vertical air handler, unlike the other ductless indoor units or even our hybrid scenarios where that's purchased as a separate part. This offers the compatibility with that 7-day programmable thermostat, which is going to be a third-party thermostat. Carrier ductless wired controllers will not be compatible with this indoor unit. Essentially, it was designed for a residential application where we're taking control of the space, obviously with ductless equipment, but we're still offering a thermostat that might be familiar to our customers, and we'll get into what thermostats we can use with that 24-volt interface. This offers static pressure up to 0.8 inches, but it's important to note on here that it does not come set up with this max static pressure from the factory. There's 2 ways of setting that on there, which we'll get into here shortly in the next few slides. During testing of this showed less than a 2% air leakage when tested in accordance with ASHRAE standard 193, and comes with an optional electric heater accessory with its own dedicated part number specifically for these 40 MBAA vertical air handling units. One important thing to note with this 40 MBAA, unlike other ductless units which have flare connections, the refrigeration connections on this vertical air handler are sweat, not flare, which means we're going to have to do some brazing on this system. Now, this does not mean that we can put a filter dryer on this system. That principle and rule still remains the same. However, what this does mean is if we're not using our press fittings and we don't have the room to get the press tool in there, or your company doesn't use press, when we are brazing, we need to make sure that we are flowing at least 1 to 2 psi of nitrogen in there to make sure that we're not getting that scale buildup inside of the pipe, which of course can clog strainers both at the indoor and the outdoor unit, which can create restrictions and of course individual zone or entire system failures depending on what type of configuration that you have. But again, this is available in a 2, 3, and 4 ton configuration, still offers all the mode features that we see with any other ductless indoor unit, timer capabilities. Our third-party thermostat is the default means of controlling the system, and then also heating setback modes and 46-degree heating setback on there. Now, of course, that's going to vary depending on what type of control you're using, because the units do come shipped with a wireless remote controller for configuration. However, if you look in the depiction of the vertical air handler in the electrical section, you'll see a little white device in there, which is an infrared receiver panel, which makes it compatible with a wireless remote controller. However, if that's not in the space where the customer is going to be at, then they're not going to be able to control via a wireless remote controller, which is going to allow you to have that heating setback feature, as you can't do it through a third-party thermostat, such as a Honeywell or an Ecobee, just because they don't have that option on there. Now, with controls for this, we have a wireless remote controller, as I stated before, that is included with the indoor unit for fan speed setup. And we have our built-in 24-volt interface, which is going to allow an integration of a third-party thermostat. And most importantly to note on here, the carrier Wi-Fi option is not compatible with this 40 MBAA. So when we look at the 40 MBAA and what's compatible and what's not, we need to understand that, one, they're going to not be compatible with the carrier Wi-Fi app. And the reasoning behind that is that because we're integrating a third-party thermostat into this ductless system for seamless control, is that we can offer the customer a third-party Wi-Fi thermostat to take the place of where carrier Wi-Fi would normally be applied on a traditional ductless unit, such as a cassette or a high wall. So that's going to be the way around that. And also the reasoning why the carrier Wi-Fi was not made compatible with this, because the third-party thermostat, because it's such a broad range of what we can apply, there are plenty of Wi-Fi options out there, such as Ecobee, for example. If we were to put an Ecobee thermostat on here, Ecobee is a Wi-Fi capable thermostat with their own dedicated app that you can use to control the ductless system from the Ecobee app. The wired controllers, which in this case, if it was compatible with a ductless wired controller, which would be the KSACN 0701, is not included, nor is it compatible with the 40 MBAA. And that ultimately stems back to the same reason that we're dealing with the lack of compatibility for Wi-Fi, because the whole idea of this was to be a residential replacement, something that we could replace a residential furnace and still use the customer's thermostat that they're familiar with, whether that be Honeywell, whether that be Ecobee, whether that be Nest, or whatever that they're asking for, that we can integrate that into the ductless system for seamless control. So when we are setting up our third-party thermostat, it's important to note that we need a standard 5-wire 24-volt thermostat for installation. So for example, if we had a system with no electric heat, we would need to set that thermostat up as a 1 heat, 1 cool option, and not a heat pump, because we're not going to use the O terminal. Okay, the W1 is what sends the control signal to the interface to be able to tell the system that it has a call for heat. So W1 is a call for heat, Y1 is the call for cooling. Now, if we have electric heat, we can set that up as a 2 heat, 1 cool option. Same thing, W1 is the call for the ductless heat pump, Y1 is the other call for cooling for the ductless heat pump, and then W2, when set up in this configuration, will tell the thermostat, or will tell the unit to be able to kick on those strip heaters depending on when you want to set that threshold on how low that temperature drops before that electric heat kicks on. And then finally, of course, we have our multi-position, which means we can do upflow, downflow, vertical left, and vertical right. But there are only 2 drain fans. Depending on the configuration, they may need to be moved for a different position. Okay, in this example, downflow requires adjusting the coil. And as I stated before, the instructions for removing and adjusting that coil are in the installation manual. Of course, if you have any questions, you can always reach out here to our tech support team at Standard Air for any questions that you may have or issues that you may have with that as well. So let's take a look at what it takes to wire up one of these, since we've discussed piping, and we now know that there is not a TXV removal kit that is required with this. All that we need to understand is that we have sweat connections, so we're going to have to braze, but when we are brazing, we need to make sure that we flow nitrogen to avoid any scale buildup that could clog strainers. So let's look at the wiring. So let's start at the bottom here. You can see your bus bar, your main power coming in. Essentially, all that we're doing is we're wiring up just like any ductless indoor unit. We're wiring up L1, L2, and S. Everything beyond or the top of this bus bar going in is already factory wired. Now you can see here I have a few notable things marked on where the signal wire feeds into the interface so that it can communicate properly with the main board, and then also the line voltage that's being sent to the interface, which it has its own transformer inside of it that steps down that line voltage to 24 volts AC control voltage for the thermostat. And then that same 24 volts is sent out from the interface over to the main board. And you'll see right here in this little dotted line is where our Molex plug is for our auxiliary heat, which is really nice with the prepackaged kits for the auxiliary heat. Depending on the kilowatt rating, all you're doing is essentially plugging in a Molex plug and then sliding this electric heat kit into a pre-designed slot inside the actual air handler itself. So it's pretty much plug and play for getting the electric heat installed in this cabinet. Okay, the biggest thing to note on here is if you look where we have this 24-volt thermostat. So we talked about a 5-wire thermostat. So of course we have our R, which is our hot, our C, which is our common. We have our Y1 for our cooling call, W1 for our heating call, G for our fan. Okay, but now you see this separate connection over here, which is auxiliary and dry. Okay, this is where we're going to wire up that W2 terminal to, or if you want to set up the auxiliary dry contact on that thermostat if it has one, you can wire that to CN22 and you can connect to either terminal. It does not matter what terminal you connect it on, like depicted in here. If you look it up to the left terminal, it's doing the same thing. But this is the signal for where the interface interprets a call for W2 as the time to turn on those electric heaters, depending on whatever threshold that you set. So the biggest thing to note on there is that your W2 is going to wire to CN22 to be able to send that control signal to bring on that electric heat. Okay. The other biggest thing on the interface itself, you'll see at the very top here, you have a set of dip switches that you're actually going to see on the interface itself. Okay. The most important ones you want to focus on are SW11 and SW12. You want to make sure that SW11, which is for the actual display or the digital display on the interface, is flipped up into the on position, which allows the display to illuminate on the interface. Now, depending on whether you're calling for heating or calling for cooling, you'll get a different numbered code, and it's always important to reference the service manual for the 24-volt interface to ensure whatever display you're getting is not actually an indication of an error, but more so of a current unit operation. And then finally, to make sure that SW12 is set properly. Now, in these particular units, the factory set point for these is that have that dip switch on, which indicates we have a ductless indoor and ductless outdoor unit with a 24-volt interface. If that dip switch is in the down position or off position, that indicates we have a hybrid configuration, which means we have a ductless outdoor unit and a residential fan coil that we're trying to hook up to. So if that switch was left in the off position, then we would get a code for communication between interface to indoor unit, because the interface thinks that we're working with a hybrid scenario when in fact this is a true ductless indoor unit and we're working with a ductless indoor and a ductless outdoor. So in this configuration for a 40 MVAA, your dip switch settings for SW11 and 12, SW11 should be on to allow the display to come on, and SW12 with the 40 MVAA should also be on to indicate that we have a true ductless indoor unit, ductless outdoor unit paired with this 24-volt interface. Okay, and if you look to the right here, we have SW21, 22, 31, 32, 41, and 42. Now, depending on the specifics of your application, is going to determine whether you need to flip these dip switches on or turn them off. Typically, what I tell guys is they should all be in the off position unless you have a particular need. So for this example, you'll see here SW31. Do we have auxiliary heat? Well, yes. Okay, well, SW31 needs to be in the off position so that interface knows that it has auxiliary heat. And when that control signal is sent to CN22, that this interface responds properly and sends that 24 volts AC control signal to turn on that auxiliary heat depending on when we set that threshold for. Of course, this information is also in the installation manual as well, and we're helping configure that. But just as a rule of thumb, it's nice to be aware of the most two important ones, in my opinion, which are SW11 and SW12, especially on brand new installations, to ensure you're not getting a communication code and you're troubleshooting an issue that really isn't there, and it ultimately comes back to how a dip switch is set. Okay, but all in all we're wiring, our power wiring communication is the L1, L2, S, and then we're just confirming that our SW11 and 12 bit switches on the interface are set properly, and then of course making sure our thermostat is hooked up to the appropriate terminals. Outside of that, everything else is factory wired. So it's pretty straightforward in terms of wiring and also piping as well. So now we've got everything piped, now we've got everything wired, dip switches are set, everything's set up. So we have one last thing that we have to do, and I kind of alluded to this in previous slides, was we have to set up the static pressure, because it doesn't come from the factory with that maximum static pressure of 0.8 inches. Okay, so there's two ways to do this. So one, you're going to need to grab your wireless controller, which you'll see on your right here, which is the RG57 wireless remote controller. Now this remote controller has an advanced service feature function on it that we can get in and set up the static pressure either manually, or we can do an automatic airflow. So in order to get into this advanced service menu, what you're going to need to do is take the backside off of this wireless controller and remove one battery. Once that battery is out of that wireless controller, you want to then go ahead and hit the on and off button to clear the screen like you see it here depicted in this slide. Once the screen is clear, go ahead and put your battery back in and put the cover on. You're then going to press and hold the mode, fan, and timer on button simultaneously until you see an F as in Frank 1 display on this screen. Now once you see that F1 come up on the screen, you then want to use your temperature up and down buttons to navigate to either one of these two codes. The first one is going to be D4. Now when you would get into the F1 setting, you'd want to hit the down temperature arrow until you see this lowercase d 4 on here. This is the automatic airflow adjustment. So when you set this and when you're getting ready to set this up on here, you want to go ahead and point the wireless controller at the infrared receiver, that little white box we talked about earlier. We want to make sure power's on to the system. Hit the on and off button to sync the wireless controller to this indoor unit. Then we're going to go to our wireless controller, which has this D4 on it. We're going to go ahead and press and hold the timer on button while pointing this wireless controller at that infrared receiver. Okay. Now what you're going to hear is an audible beep. Once you hear that audible beep, you know that command was sent to the unit, and then what you're going to see next is this fan slowly start up. And once you see the fan slowly starting up, you want to then go ahead and put the cover back on the air handler itself to make sure that we don't have that open and it's not sucking return air from the space around you, because the system is essentially going to try to balance itself out and figure out the static pressure that it needs to operate at to ensure that it's getting good airflow to all of the zones that are on this system. Okay, this process takes about 3 to 6 minutes. After the system stops operating, you will see the fan ramp down and everything shut down, and that's how you know this automatic airflow adjustment is complete. Okay, once that's complete, then of course you're going to go back in, run the system in cooling, take a delta T reading to ensure your charge is correct. We know, and if you don't, 20 to 30 degree delta T in cooling is an acceptable range. If we're running in heating, we're looking for a 30 to 40 degree delta T to ensure that that charge is correct. Okay, now this is for the automatic airflow setting. If for some odd reason, because we don't live in a perfect world, that this doesn't set up properly and you're not getting the correct amount of airflow to every zone, you also have the option of going into the static pressure setup manually. Okay, so what we're going to do is the same exact thing that we did to get into that advanced service feature on the previous slide, except now instead of going to that D4, we're going to navigate to our code E as in Eric, 9. So E9 on that wireless controller is what we're looking for. Okay. Now, if we look to the right, you'll see this chart here that has the model number of the tonnage of the equipment with different static pressure settings. So we see our 2, 3, and 4-ton models. So of course, we want to find our applicable model. So we'll say, for example, we have a 2-ton model, and now when we're at that E9 code on that wireless controller, we want to hit the mode button, and you're going to see a 1, 2, 3, and 4, which is essentially SP1, SP2, SP3, and SP4. Okay, now if we look over to the right here, it'll give you different fan speeds, the static pressure that it's going to be at, corresponding with the CFM that it would deliver at that static pressure. Okay, so this is where you're going to use your chart and essentially figure out what CFM and static pressure is going to match the CFM that you need to deliver to every single one of those zones that this air handler is serving. Okay, so for example, if you needed, let's just say 0.3 inches of static and you needed 1600 CFM, okay, you would go to your SP4 setting, and then you would want to set for SP4, which means at 0.3 static, you're getting 1592, which is just a little bit under 1600 CFM to deliver the proper airflow to the space. Now, of course, not everybody takes into consideration of measuring the static pressure, figuring out the CFM. Usually, if you need a decent amount of CFM, I typically go between SP3 and SP4, SP4 being the max that we can push that unit to. Okay. So what you're going to do on your wireless controller is you see that E9, you're going to go ahead and press the mode button. You're going to see a 1 come up. You then want to use your temperature up and down arrows to navigate to 1, 2, 3, or 4, which we know by looking at this chart is SP1, SP2, etc. Once you choose the appropriate number, you then want to take your wireless controller with that number that you've chosen. So in this case, we'll take number 4 on the wireless controller, point that wireless controller at the infrared receiver, and press and hold the timer on. You'll hear an audible beep followed by the number 4 displayed on that interface to indicate to you, 1, that the command was received, and then the 4 to also signify that that command was accepted, and this is what we've changed it to. And then, of course, you should see your blower speed ramp up, and then, of course, you'd want to make sure that you are getting the correct amount of CFM or conditioning to the actual spaces to ensure that on the worst days of the year, whether it be the hottest or the coldest, that we're going to deliver the correct amount of CFM to be able to keep that space comfortable. Okay. So you have 2 options: automatic airflow, manually setting the static pressure. You want to try out automatic airflow? Be my guest, absolutely try it. If it doesn't seem to work out, or it's just not what it actually, or at least what you thought it would be, you can always go back and manually set that static pressure. But that's something that we need to do on every install, whether we're dealing with a 40 MBAA or whether we're dealing with a 40 MBDQ, which is the horizontal ducted units, which most of you, if not all, should be familiar with by now. And if you haven't been setting that up, then chances are that's probably why you got some return calls on why the unit's not delivering the correct amount of airflow. And typically, you probably would have talked to me and then found that you actually have to set that up. So it's always important to reference the static pressure and CFM charts depending on what program that you want to run that at, depending on what CFM needs in space. Okay, so 2 options on there. So when we're talking about vertical air handling units, such as this 40 MBAA, what we're doing from the installation perspective is wiring up L1, L2, and S. Okay, we're also verifying that dip switches SW11 and 12 are set correctly for the application. Now on the 40 MBAA, we talked about both of those switches being in the on position. And then finally, once everything is wired up, everything is piped. We've used nitrogen while we were brazing to avoid any scale buildup. Now we have to go back and program the static pressure for the machine before we start doing our testing. And of course, that can be done 1 of 2 ways, either manually or we can set up the automatic airflow adjustment, which takes about 3 to 6 minutes to configure itself. Okay. And one thing I always note at the end of every tech tip, please keep in mind and watch out for our fall 2021 training schedule. We're going to still be offering our workshop 2-hour classes, which focus on installation, troubleshooting, application, product overview, and then also our traditional 4-hour classes, which essentially cover everything in a 4-hour period that we offer at each one of our branches. And of course, I am your first point of contact for VRF or ductless technical support. If for some reason that I am not available, I'm on vacation, I'm sick, whatever the circumstance may be, I am only your first point of contact. There are 3 other gentlemen in our technical service department that are always more than happy to help you with any of your VRF or ductless technical support needs. And then, of course, if you need to get in touch with a ductless product manager or a VRF product manager, both their names, contact information, and emails are listed below. So hopefully you guys have a little bit more understanding of what this 40 NVAA vertical air handler is, how we set it up, what's compatible, what's not, the subtle differences between a hybrid configuration versus this vertical air handler information. And of course, if you have any questions, if something didn't make sense, or if you just kind of want to run something by me, you're always more than welcome to give me a call at the office number and my direct extension listed on the screen, or shoot me an email anytime. I'd be happy to help you any way that I can. Thank you guys for taking the time out of your day to sit through this. Hopefully you took something out of it, and I'll see you on the next tech tip.